Okay, so welcome again to this ADS office hours. And today we are going to talk about modernizing ADS infrastructure in particular. And it is quite surprising, at least to me, to think that ADS has been with us now for 27 years. That's a huge period of time. And of course, things has changed. Things have changed a lot since then. There is new technology in the market, and the decisions that were taken more than 20 years ago, maybe now, may be different, and we should go a different route. And actually, it's just time to revisit what we've done for these 27 years and try to see if we can come out with something better, something more modern. And maybe to start, like to give an overview of how ADS Classic works, it would be nice to take a look at this picture. And this is like a very schematic, very high-level way of describing how ADS Classic works. And basically what we could say is like, okay, for ADS Classic, we have a bunch of providers that are going to send us data in different formats. Of course, it can be publishers, can be archive, it can be many other kind of means. And all this data that we receive, its file, its information is going to be structured in a different way. So sometimes we receive just plain text files, sometimes we receive XML. The XML files, each publisher may decide different tags, different structures. So this is where ADS Classic comes in, and we have a lot of processing programs that are going to take all this data, is going to homogenize the data, and is going to save in a homogeneous way all the metadata for all this article in plain text files. Plus, an index is going to be built to be able to do quick searches over these files. Of course, we have to think also that ADS is not just an automatic machine that works without us doing anything. We have actually curators that they take care of the quality of this data. So the whole process is thought in a way that it's relatively easy for curators to correct things. And that's one of the things that we need to take advantage of it. If any of you have, if you ever detect a problem that you think that we should correct, some bad misspelling and some names, some title, you can always contact us. There are people behind this project that will react and will correct things for you. So okay, we have all this process, and of course, once the data is in a homogeneous way, we need to offer the possibility for users to interrogate this data, to search and get results back. And for that, we have this ADS Classic web front end. That is what we are all used to use, or at least until very, very recently. And that's the way how we are going to be able to search on all these files. And well, when you see this picture and how things work, and as an astronomer, you say, yeah, I mean, things are working just fine. I mean, why do we want to touch this? This is just perfectly fine, right? But actually, when you start poking around and you start really understanding what's the status of this infrastructure, you realize that actually, well, this strategy of having this index with plain text file is maybe not the fastest solution nowadays. It was a good decision at the time. It was a good decision to do a custom kind of a custom search engine, but nowadays we have other tools that we can rely on it, and they are more tested and faster. So that's something we could improve. Also, we have to think that this is like quite old, and it's not very flexible. And by flexible, I mean if we need to add some new field to our database in Classic, it becomes kind of a pain because it's not that easy. And for instance, just to mention an example, if the moment that we wanted to add the ORCID's IDs, these identifiers that can identify, I don't know, John Smith, you can disambiguate different people just by using these identifiers. It's like, what do? We create a new field, and then we have to go through all kind of verifications to make sure that we are not breaking anything. Or, for instance, what we ended up doing was adding this information to the affiliation field, which is, of course, not perfect when you want to search things. So this is kind of a difficulty that we have. And also, when we look at actually the code, how these processes, how they are implemented, most of them are written in C, with parts of written in Perl. And all this code is really like uncommented code. The main developer is not with ADS anymore. We don't have unit tests. It's really difficult to maintain this code, and it's C. So if you have developed C, you know how painful it can be. And of course, also C. Well, C it's of course it's a fantastic language for many things, but also it's like you have to be very careful with saying what you do. It's easy to create bugs that can be exploited by hackers, for instance. So it can become kind of a security problem also for the project, because who knows the kind of bug that we may have on our systems that we are not even aware of, and it's better if we will feel way better if we go with the technology that help us minimize this vector of attack. So it's actually now. I mean, I remember before coming here to work with ADS, it was like, yeah, why? I mean, why should we change this? But now when you start to look at these pictures, like, yeah, maybe I understand why these people are doing this effort of changing and trying to improve things. And it's not only that, because ADS Classic is running on servers here at CFA, which means it's the US, but of course astronomers are all over the world. It's not only US, and there may be places where, well, the connection to reach our servers here is not ideal. It may happen also that something goes wrong in our server room. Somebody unplugs something, and suddenly, poof, there is no more ADS, which is it's a problem, because astronomers, they can work 24 hours basically, because you have those observers and those that work during the day. So what we came out here in the past is with this system of mirrors, where we are actually distributing our data between different sites. So we have ADS Classic also in some European countries, in Chile, and in many parts of the world. And what we are doing right now is synchronizing between all these mirrors what is the text, the code that runs the web interface, all the metadata information, but we don't synchronize user accounts. So basically, what this means is if you have an account at CFA, so here in the main site, and you try to go to somewhere else, well, you don't have your libraries, you don't have your stuff. Also, you have to think that this is not like an automatic thing that happens like, hey, oh, the servers at CFA are not working, let's redirect automatically users to some other location. This is not at all how it works. Actually, the users have to know what is the URL. So they will say, oh, this is not working. Oh, do I know what was the mirror that is in Europe or somewhere else? And then type that URL and go to the new place. So as you can see, it's far from ideal and far from what we are used to have nowadays with current technology. So, given this picture that we've drawn, one of the things that we said is, okay, let's go. Let's try to modernize everything, and we're going to start by just getting rid of this part, and let's start processing this data. This initial data. We still rely on a small piece of Classic that we plan in the future to also replace, but nowadays it's still there, so we still rely on part of this code. And basically what we've done is we've started to implement some modern pipelines. Here, the idea that we have approached the problem is, okay, why don't we just try to do things with different components that are going to be independent one from the other, and it's specialized in particular tasks. And that's what's going on here. So we have things like the full text extraction, which, by the way, that's information that goes to the new ADS, but Classic does not have full text. So you cannot do full text searches. We have pipelines for metrics, bibliography, and many others that are not listed here, and they are all kind of coordinated with a main pipeline that is called master. And actually, if we go into the details and we see how is this actually implemented, how does this work, we are using a system of queuing messages. So what happens is you can receive messages from all these pipelines, like, hey, I have a new full text from one article, and this is going to create a message, and some workers are going to be just sitting there waiting for new messages to appear, and when there is a new message, one of the workers is going to take that message, and it's going to start computing and doing the stuff that it needs. Hey, there is a new citation, hey, there is a new record. So all this is happening in parallel with these workers. And when I say workers, we really need to think about computer programs that are running on some machine. And the nice thing of this setup is that actually, well, if you actually check the numbers, we have, every time we have more and more records. So this also means that we need to process more and more data that is coming to ADS. So the good thing of this setup is like, okay, things keep increasing and we need more workers, we can just use more machines, buy more machines, and increase the number of workers, and we can scale up things pretty easily. One thing to note here is we are using, for this setup, we are using this GravitonQ software, which is actually a software that is used widely, worldwide, by many companies, and it's open source. So we are actually relying on something that already exists, something that is being actively developed. There will be new features that we will take advantage in the future. So we are not just right now building something custom only for ourselves, but we try to not reinvent the wheel and use software, well-tested software that already exists in the industry. Then apart from all this messaging, all this work is going to end up being sent to this master pipeline, and then the data is going to be stored in the database, and a real database, not something, again, it's not something that we've invented, but Postgres SQL database that, again, it's something that is widely used, widely tested, and you have many contributors behind. So it's something we can rely on. But of course, this is not the only kind of database technology that we use, because in the NADS, what we contain is basically a lot of text, and we need to search text very efficiently, and Postgres is not the best place to do that. Postgres is very good to store and keep track of things, but for searching text, it's better to go with other technologies, and it's here where we are using something called Apache Solr. This is a search engine that provides very nice features. It's fault tolerant. It allows to duplicate the data very easily. It scales up, and the list goes on and on. And of course, again, it's something that is used by many companies. We are not the only ones. We are really standing on the shoulders of giants. Okay, so we've seen how, from our initial data, what we are doing now with our modern pipelines, and how we are ending up with all the information that we can search in this search engine. But still, we said that we were going to get rid of this part, and we kept talking about data. So what are we doing exactly there? What's going on? So for the website, the front end, the way that this was designed for Classic was kind of following a monolithic architecture, which means basically that what it is, the user interface and all the business logic, or even the access to the data, is everything bundled together. And what what we did is, well, we learned what's going on nowadays in the industry, what new patterns have emerged that may be more useful than following this approach. And this is kind of what we've done with the pipelines. We decided to go with this microservice architecture for the front-end part, where what we are actually doing is we are creating microservices or services that are specialized in just one single activity, and all of them can be accessed through an API, and that's going to be our design. Well, this is actually the new design, how the new things work in the new ideas. And with this design, now the nice thing is that we could say, oh, what if we can just use cloud technology? We could go to Amazon, and what we can say is, hey, we go to Amazon, we create some of the virtual machines that Amazon let us create, and we can put each of these microservices in one of these machines. So now we do not rely anymore on a server crashing at CFA or somebody unplugging something, but really we have things on the cloud. Although still we realize that even if that was a nice approach, still was not the most efficient, because you can imagine how of all these microservices, there may be some that are more CPU consuming. For instance, maybe there is at a certain moment in time there is not so many people using the libraries, but there are many people exporting BibTeX, for instance. But we are in this schema, we are dedicating the same amount of resources to all these microservices. So trying to improve that is when we realize that, oh, actually there are other technologies on the market that we could use, and we finally decided to go with Kubernetes. Kubernetes it's an orchestrator that is going to take care of all these small components. I was going to say, for instance, oh, okay, so actually, given the current traffic, I just need 2 machines in Amazon, so this keeps being run on the cloud. And I'm going to actually put together these 2 microservices, the API gateway, I'm going to put this other. And if at any point in time there's an increase in traffic, like, I don't know, gravitational waves have been discovered, or anything happens that we start receiving more traffic, Kubernetes will detect this and automatically say, hey, Amazon, create a new virtual machine, I'm going to put the new stuff there because we are having more traffic than usual. So that's actually a pretty cool way of managing this need. So now we can scale up and down very easily, and it's automatically managed by Kubernetes. So okay, so we've seen again our modern pipelines. We've seen how Kubernetes manages the microservice and API access. Something that we were still missing here is we mentioned that we have all the data in this solar instance, which is right here locally in CFA. But we have also another instance in Amazon, and from time to time there is a cron job doing this. There's windows open that are going to be used to synchronize the data, so that all the data that we have in Amazon is always in sync with the latest records and latest updates happening in AWS. So there is this connection. Of course, once you have all this infrastructure, now is when we could, by using this API, we could create a new user interface. That this is what the user basically sees when it accesses the new ADS. And this new ADS, it's using JavaScript, modern frameworks to do all kind of fancy stuff that we couldn't do before in Classic. And I understand that there is a small transition effort to do. You need to learn what the new things are, or what are the things that I used to do with Classic. How do I do it with the new interface? But as you can see, the effort that is behind this, it's actually justified by the need of modernizing the whole infrastructure, the whole system that we have here at AWS. So as what we've seen so far is we have modernized the architecture. This allows us to scale up and down, to not be dependent on one server here in terms of also with Amazon, we have the possibility of duplicating the data somewhere else in the world quite easily. We are, as you've seen again, we are using well-established software that it's tested by many other companies and users. They have a broad community that supports new features are being developed, so we're going to improve our system just for free because we can just adopt whatever they implement with this software that we rely on. And then we are really using open source everywhere. So every time, every piece of software I mentioned is open source, and even what we are developing here in-house, all the ADS software is in GitHub, it's open source, anybody can see the code. If people want to contribute, they are free to contribute. They will see actually how we are developing because we follow a pattern where we issue pull requests frequently, our code reviews and so on. And all this is happening in a public, very transparent way. And that's everything I had for today. So thank you very much. If you have questions, I'm happy to take them now.